the project is titled Impulsive Control of Underactuated Systems. So we are trying to use impulsive forces in the set of admissible control inputs. If you look at the control literature, you'll find that impulsive forces are not typically used because these are very large forces that act over very short periods of time, and although there is theory as to how these forces will affect the dynamics of systems, they are not implemented in practice. We realize that there are many actuators that can apply impulsive forces. Within the human body, for example, when we run or we jump from a height, our muscles apply impulsive forces, very large forces for very short intervals of time. And we believe there are many actuators that can mimic that. The advantage of using impulsive forces is it can do a large amount of work in a very short period of time, and therefore it can arrest the fall. In the case of human beings, when we jump, we don't fall down after we land on our feet because of impulsive forces. Similarly, if you use impulsive forces with robots, the range of activities that they can do will greatly increase. Robots currently are limited in what they can do because they use very traditional bounded forces. But if you included impulsive forces within the set of admissible inputs, then it is expected that they will be able to do a lot of tasks better, or simply they can do a lot of tasks that they cannot do now. Well, the robot, we are trying to develop bipeds, mainly because bipeds we think in the future bipeds will be used as service robots. As human beings, we are bipeds, so we have an environment around us which is best suited for our locomotion capabilities. Everything we do is well suited for us. So robots that are bipeds will be able to share such environment better with us. If it were wheels, it would not be able to climb stairs, for example. It would be stuck there. It would have to use an elevator. Whereas if it were a biped robot, it could climb stairs with us. And we envision in the future more and more bipeds to be used in home as service robots for the elderly, or for people who need help, assistance, or as assistants, personal assistants. So this is very futuristic, might sound, but it's already beginning to happen. Giving examples, it could be underwater vehicles. If in fish, they use these kind of mechanisms, like in sea starts. When you scare a fish, it quickly darts in one direction. They coil up their body and then they suddenly release a whole amount of energy and they shoot in one direction. So if we could mimic some of these things in nature, we could perhaps have underwater vehicles that can have much better capabilities in escape, in mimicking escape maneuvers. Also, it can be used for missiles and other satellite reorientation in space, free-flying objects in space like satellites and missiles. Well, the robot that you saw was not a pure biped. It was our first attempt to build a robot, and we were successful. We learned a lot. So now we are going to build a true biped where we would have point feet or point supports, and there will be impact forces when it starts walking. The robot you saw did not have that. It had rocker kind of feet, and it was purposely built that way so that it could emulate a rolling wheel rather than human-like walking. But that robot would not be able to climb stairs. But what we were able to do is we'll learn a lot of things about stability and other issues. So now we would like to take it to the point where we can have feet like humans so that it can climb stairs. Stair climbing is one of the challenging problems. Not many bipeds today can climb stairs, and our immediate goal is to be able to climb stairs because that's a challenging problem and we would like to address that problem.